Okay, so for this last session, or I guess it's the penultimate session, since we'll have a wrap-up, Frank Wuerthwein and myself are going to talk about a national-scale data federation, and it's a partnership between OSG and Internet 2 that we're really excited about. And so Frank's going to kick it off, and then I'll come back, and then Frank will finish up. So.
Okay, so we're going to start with a little bit of context and vision. So the first statement worth making is that science is a team sport. And it often requires distributed teams of people and resources. And equally often, people actually bring resources with them and want to integrate. And there's lots of in-kind contributions. It often requires collaborations across science and cyber infrastructure. And all of this wants to be enabled in order to maximize science given fixed dollars. And so once you acknowledge that, then there are some organizational challenges. And in order to accomplish science, it requires a coherently coordinated division of responsibilities from data sources or sinks through the network to cyber infrastructure teams to science teams. So, and what we're trying to accomplish is define a layered approach where you have at the bottom, say, the sources and sinks, then in between you have the research and education networks. Where's my, there we go. The research and education networks, then a layer of cyber infrastructure that is effectively service operations, and then science collaborations on the very top. And in order to show that this can be done and figure out where the pain points of communications are, we're deploying a Pathfinder. And so we deploy a national scale data federation that is open for all of science. And we think of it as an exemplar CI application to prove feasibility of this layered approach. And so there is going to be storage hardware owned and deployed by different organizations. Some of the storage hardware is on endpoints, some is inside the network backbone. There's network performance engineering that is responsibility of the likes of PRP, Internet 2, and the regional networks. And there is data federation operations responsibility of OSG and science support responsibility of OSG. And so I'm going to talk a little bit about the technology, but keep that fairly light, just so that you have a little bit of a sense of what is actually being talked about. And so the beast is called OSG Stash Cache. It's a data federation and built on tools from the LIC community. At the LIC community, this is today in production at the tune of about 150 petabytes of disk space, globally distributed in ranges from sizes of, say, 100 terabytes to 10 petabytes in terms of per site. And there is multiple such data federations, one for CMS, one for Atlas, and if you take 200 petabytes, I call it exabyte scale, 0.2, what's another digit between friends, right? The distributed data sources within a discoverable namespace. It supports highly dynamic tree of data origins and caches. In effect, you can produce any tree architecture you want, and you can add any origin you want to it. In other words, an organization can come with a data origin of their data, they get a piece of the namespace, and they hook into the tree at an arbitrary location, and then just can surf out through all the caches, et cetera, et cetera. Each cache, the cache owner can define what part of the namespace they want to actually cache, and therefore you can effectively, all caching policies are local. It's highly dynamic. Caches and endpoints can come and go at will, and the system will just work. So what are the implications? I said the first one already. An organization can join the federation with their own data origin, their own partition of the namespace. A cache owner can decide on caching policies. And what this effectively allows to do is we can build community-specific storage overlays inside the data federation. So you can, in principle, have one global data federation for all of open science, But reality is that inside of it, there are sub-federations that are where certain pieces of hardware will only cache certain parts of the namespace because they're owned by certain organizations. Now, what's the context within which this is used? The context is the OSG Compute Resources. On this, you will recognize this as the US map, I assume, and every red dot is a cluster. It's a compute cluster in general. Right now, today, it aggregates about 200,000 Intel x86 cores for about 400 projects across about 36 fields of science. And now what we've done is we've added origins, and there are 3.5 origins, meaning there's 4 origins, one of which is planned and actually not deployed. The 3 origins that are already deployed is one at Fermilab that is only based for its HEP experiments that it supports, largely the intensive frontier, if this means anything to people, but also some dark energy survey data, and I'll talk more about that later. Then there's one at the University of Chicago. That's the general OSG community. That's where you find the data of your favorite bioinformatics person. I see one sitting there in the audience. Alex has data in there, Alex Feltus, and the like. Then there is one at Caltech. At Caltech, it exports all of the public LIGO data into the federation. It also exports the private LIGO data, so we have both the public LIGO data and the private LIGO data just under different access privileges. And then at SDSC, the planned one is the Flatiron Institute / Simons Foundation, a private foundation that has lots of data that wants to use SDSC disk space that they have bought to move out to the world. I think we're switching here.
So I'll talk about the first manifestation of the partnership that we've developed is this idea of a pilot effort to explore expansion of the stash cache service that Frank was talking about into the national backbone. The idea is that we can experiment with different scenarios. So for instance, we've chosen the locations that you see here, the Chicago data center, New York data center, and then in partnership with our friends at GPN, Kansas City. The idea is that potentially we might decide that we need to experiment with the locations potentially. So these were placed to be actually near, and I've kind of show it on the next slide, to actually do some experimentation where we can potentially either change how the particular nodes are configured, what the locations are, et cetera. And then certainly, as kind of referencing back to Howard's talk earlier, as we think about scaling some of this stuff out, the interconnection between these various points, we can experiment with various virtual network services, et cetera, where we try to optimize for manageability, resiliency, security, that kind of stuff, et cetera. So, so as I mentioned, so here are the locations, Chicago, New York, and Kansas City. So these are the initial backbone nodes, and as I mentioned, we're working with our friends in Kansas City at GPN for the Kansas City node. Now, the next slide will show the endpoint caches. So the initial placement was really based on trying to get us close to those endpoint caches currently. As we continue to experiment, we may find that, well, that location proximate to the endpoint caches is not the right, configuration. We may need to move them to different locations, et cetera. So, again, we're starting off from just an idea that we're going to, try things and see what works, et cetera. both from the configuration as well as location, et cetera. So I did want to talk a little bit about, before I dig into the deployment, talk a little bit about how this fits into the broader context. So we really hope to learn a lot by deploying these nodes for two pilots at once. We're going to use these boxes that are going on the backbone, both for this caching pilot as well as some of the work we're doing directly with the NRP group. Right, so and really leveraging that idea of the containerization and taking advantage of it as much as possible. We're hoping that this model will be extendable so that we can think about adding more science infrastructure efforts and the science collaborations they support. Again, leveraging this containerization effort. So, I just had a great conversation with Lars Fischer on the way up here. We're certainly thinking very much internationally. We have some ideas. Frank is actually going to address one opportunity that we have potentially for some international partnerships that hopefully manifests itself fairly quickly. And lastly, a point here about how we should look at those thinking about from a network infrastructure perspective. We should certainly take the learnings that we get here and use that to make some appropriate decisions about the kinds of investments that we make in the regional infrastructure, in the backbone, and at the campuses. Okay, so just talk a little bit about the deployment. These are the boxes that we've chosen for deployment in New York and Chicago. I think the spec is a little different, the one we're borrowing from James for the initial pilot. And all these are going to be a little different. Here's kind of what we're thinking in terms of how we're going to structure the relationships. So the hardware owners are going to be responsible for the normal power, networking, hardware, maintenance, et cetera. Operating system, and certainly maintaining the Kubernetes local installation. If you refer back to the previous talk, as well as Dima's talk on Sunday, there's information about how to join the Kubernetes cluster. Again, the hardware owner is going to be responsible for getting into the cluster. From a PRP perspective, we want those folks to be able to maintain the network performance container, collect and inspect the routine network performance measurements, and then do any kind of debugging that's needed. Now note that one of the NRP scaling issues kind of comes into play here. This responsibility, as we scale out nationally for this, probably doesn't scale all that well. So we really need to think, about actively, I think this is actually a potentially good area for sort of some active research into how we organize to support these kinds of trials and partnerships. And then I'm going to turn it over to Frank to talk about some of the OSG responsibilities.
So an OSG is responsible for maintaining the data federation cache container on the Fiona. That means it does remote management via K8S cluster tool. It defines the caching policies. It defines the data federation tree architecture and corresponding services. It therefore also defines the runtime environment that the application sees that allows the application to actually access the data. It defines the which cache gets used from which location, the auto-discovery, in other words, of what caches to use when you're running where, and that sort of thing. It collects, inspects, accounting, and monitoring of data federation transfers. That will be done in collaboration with Internet 2 because, as you've just heard, Internet 2's objective in this is to understand what's the usage patterns, where should we have caches in other locations, what kind of added value is actually provided to the science, et cetera, et cetera, et cetera. So when, where, how much additional storage needs to be deployed, and then the runtime environment, I said already, and then, of course, provide education support to science communities is also OSG's responsibility, meaning teaching the scientists ultimately how to use this stuff. Now, I want to switch gear a little bit and talk about the science that today uses this caching infrastructure, because the endpoint caches that you've seen a few slides ago have been alive and humming for about a year and a half, or thereabouts, a year or so. And so we do have a transfer accounting for about 8 months. And we do transfer accounting by namespace. So as I said earlier, a project gets a part of the namespace, and then we record how much data is read from them namespace through the caches. And in OSG, this is all for the smaller collaborations. In other words, this excludes the LHC. It's the likes of individual PIs or their grad students. What you see here as Jean-Jacques is actually a bioinformatics application from Nebraska, and I'll talk about this in a second. The second largest one is MINERVA. That's a Fermilab experiment in neutrino physics. The third largest is the Dark Energy Survey, and the fourth largest is LIGO, and the fifth, all of this in the last 90 days, is Alex's grad student. And so I'm going to talk about the first four because I've talked about Alex so often that I no longer do. So I'm going to briefly describe the science of the top 4 science applications, and the by day data use is here. And you can see that there are long periods of time where none of the current users are actually active. And that's just the nature of the beast. The top data consumer within the last 90 days is a bioinformatics group from Nebraska. They effectively do an analysis of peptide bioactivity, asking questions like, what's the role of diet and microbes? How does this lead to the composition of your gut microbiome? And they do this as a part of analysis of bioinformatics data, and part, actually, if I understood correctly, this slide, this is their slide, not mine, and I'm not a bioinformaticist by a long margin. There is a combination of data analysis and simulation. The second one is a little bit closer to my wheelhouse of particle physics. It's the MINERVA experiment at Fermilab. It does precision measurement of neutrino interactions on 5 different nuclei. Its purpose is fundamental physics input for current and future neutrino oscillation measurements. And what it does with this infrastructure, it stores input files for simulations in Stash Cache, and then goes to town across OSG and does simulations with this as an input, and reuses these flux files, as they call it, over and over and over. And they use a combination of CMFS and XRD, and I've linked in here the publication where we describe how that works for people who want to have a more technical understanding. Effectively, on every worker node, you fuse mount CMFS, then you have a piece that just says, I'm going to use the application would effectively do a POSIX file open on this construct, and everything up to the last bit, the actual file name, is cached inside CVMFS so that you can do ls, find, and all the nice things that you're used to from a file system. And that last piece is actually accessed via XRD, and that's the big data movement engine. The next example is the Dark Energy Survey. The science, the Dark Energy Survey does a number of different things. The stuff that is mostly run on OSG is the piece that does transients. They have a Planet 9 search and a bunch of other things that are basically transient phenomena. And the transient phenomena that has become the most talked about was their joint discovery with LIGO, where they saw a binary neutron star merger, which runs under the name gibberish 170817, giving the date of observation of the gravitational wave. And the link here, if you click on that, you get to the paper that describes the DES observation that goes together with the LIGO observation. that gets me to the next example, LIGO and VIRGO. LIGO runs 2 interferometers. Each of them is 4 kilometers on 4 kilometers at right angles. And in addition, there is a completely independent experiment, an instrument called the VIRGO collaboration. That's a 3rd instrument. And the 3 instruments allow you to pinpoint the location of a gravitational wave. In other words, they jointly analyze their data in order to actually point in the sky where the gravitational wave came from. And as a result, they need to coordinate, they need to transparently be able to run on VIRGO resources in Europe and LIGO resources in the US. And that's what OSG makes possible. So what I've given you here is a pie chart of LIGO VIRGO's CPU consumption for, I believe, the last year. I can't remember 100%. And you can see that the biggest one is an allocation of the Comet supercomputer, and then the Netherlands, 2 different places, and then France, my cluster in UCSD, Wisconsin, a place in Italy, some place in the UK. Bottom line, roughly half, give or take, of the total consumption comes from Europe. That then, of course, begs the question, given that LIGO's reuse of data is at the order of 1,000 times for a given file, for a given analysis, right now they actually pull every file to the application when they run in Europe. So every file moves over the Atlantic 1,000 times. So one of the things that we want to do is put a cache in Europe. So that justifies the NREN, and we have an ongoing conversation with somebody in Amsterdam of putting it in the Netherlands, given that the Netherlands is the largest consumer of resources or provider of resources. The DOI here describes in a paper how LIGO does this together with OSG. In addition to LIGO's internal data, LIGO has also made its public data available via the same infrastructure. And it just started if I look at this, it started about 20 days ago. This is the last 30 days of use. And this is the beginning of serving a wide range of public data via our infrastructure. Basically, within the next year or so, we're going to trying to figure out what other public data sets should we have as origins feeding into this as caching infrastructure. And one of the things that I take away from this meeting is to have a serious conversation with Alex Delay about the OSN being an origin to this infrastructure, because we actually can make this technically possible, I think. Finally, summary and conclusions. We started to integrate storage hardware into the network backbone in the OSG Data Federation. We're doing this as a pilot in order to prove that there is actually a layered structure that you can do that makes deployment manageable. So every organization in the stack knows exactly what they're going to do. And we need to develop an efficient way to experiment, apply what we learn to improve the infrastructure and services. And finally, our pledge to all of you guys and your friends and colleagues: we're open to pretty much anything you want, meaning we're open to add additional CI, additional sciences, additional storage. And the way that we would do so is if you were to join your Fiona into Dima's Kubernetes cluster, we will run on that storage a Data Federation cache. And magic will happen and science will get done. Thank you very much.
Okay, any questions? Yes.
So one thing that's been very helpful from both OSG and Exceed to help get a handle on the facilitation work is being able, from a university perspective, to find out who the users are from your university. Because as we make these national infrastructures and the commercial infrastructures more and more easily used and have less and less friction through the central, which is all good stuff, we need to still be able to do the matchmaking of being the help down the hall. And so that transparency of who's using it really is very helpful. So please build that in.
So if you and if I was sufficiently adventurous, I would show you in real time that it's there, but I'm not that adventurous. And so the OSG accounting system called Grok, because we have too many nerds in our on staff, that is ordering the accounting data by facility, by organization, and by institution where the scientists come from. And so you can actually go there, look, and then sort of select and oh, I forgot, by field of science as well, and sort of try to decipher the matrix and therefore get a sense of what's going on.
Yeah, Jerry.
Just quickly, did I miss it? How large were these caches? The stash cache?
The ones deployed range from about a few tens, say 20 terabyte to 100 terabyte right now. And so because we wanted to deploy something that is cheap, show that the concept works, and then we're going to move forward.
And those were 10 or 100G connected?
Almost all of them are 10G connected, but the Internet 2 ones are the first ones that we are connecting 100 gig because they have dual purpose. We wanted to have a network performance at the same time as the cache function.
Well, let me, that's all great. Let me just suggest, do you have European partners in that?
Say again?
Do you have European partners?
I am negotiating right now with a partner in Amsterdam.
Talk to me also.
Okay. Good. I very much am looking for a European partner.
Yeah, the guys at Norgenet are not too bad.
I'm just curious, as these are deployed, are you collecting metrics so that you can show some nice visualization of what's coming in versus what's coming out?
Yeah, so we collect metrics is a funny thing, right? You sort of start with something that you think you need, find that you don't need that, but you need something else. And so it's a work in progress. So right now we have the following metrics that I remember because I've looked at them. We have metrics by server, meaning by cache. We have metrics by where the pulling comes from. We have metrics by namespace, what part of the namespace is being pulled. And we have, for a subset of the tools, we have metrics by user and failure modes. Because we have effectively two types of access mechanisms. The one that I showed is the POSIX-like file open. There, we actually don't have metrics for identifying user and failure modes because we haven't quite figured out how to do that yet. We also have a tool that just CPs out. Basically takes a file, copies it in the local environment, and then goes to town in the local environment. For that tool, we record the user, the retries, and failures, and all kinds of stuff like that. And so it's in progress. We have learned the hard way that there are metrics that we should have had and don't have. We've had very strange failure modes, which ended up being having what's it called? TCP/IP losses, transfer losses at massive scale when a single server gets overloaded, and we didn't have that metric. I mean, we didn't have that recorded. So we're going to add more and more of this as we figure out operational issues.
Thank you. I was just, some of the, I think visualization would be real powerful if you're trying to recruit other folks, maybe even, for instance, the Kansas City node was referenced. I mean, might inspire us to add more storage.
And there is a all of our metrics are kept in a Kibana infrastructure in Chicago. And so few people even know how to find this. So we have a little bit of work to do.
Yeah, I mean, it'd be interesting too to see if, obviously, we're, as we're rolling out some of this stuff in the network too, we're going to be collecting measurements. The correlation there might be quite interesting. So,
and I think that I really want to, what I want out of this is I want not everything be my problem. And so this stack that I talked about that we talked about on the second slide, that's the golden thing. Because I can delegate things that OSG doesn't have to do.
Other questions? Okay. All right. Thanks, you guys.
thanks very much.